This is a video recording for Chapter 12, Part 2 of our notes. Okay, so if you have gone to the GeoGebra website to investigate the properties of a parallelogram, this is the summary. So our opposite sides of a parallelogram, they are parallel to each other. So over here, then the other opposite sides, like this. The opposite sides are also equal in length. So our distance AB, will be the same as the distance for DC. Similarly, for BC, it is equal in length to AD. Okay, move on to the next one. The interior angles are supplementary. So previously we learned that supplementary means that they add up to give us 180 degrees. So we are talking about this angle here and this angle over here. And then for the opposite angles of the parallelogram, they have to be equal. We're referring to these two angles being equal and these two angles being equal. So angle ABC will be equal to angle ADC, whereas for angle BCD, it will be equal to angle BAD. Next, let's look at the properties of the diagonals of our parallelogram. So the diagonals in the bottom portion of your page, the red line and the blue line, they bisect. So bisect means it splits into two equal halves. So our AO, okay, this portion over here is equal to this portion, OC. And similarly, our BO value length is the same as OD. So we can see it from the symmetry also. Next page. Okay, so we talked about the area of a parallelogram in class already. So it is the same idea. You cut out a piece of the triangle over here. You can shift it to the other side and you will form a rectangle, which you are all familiar with the formula for area of a rectangle, which is the length multiplied by the perpendicular height. Okay, so using this formula, we also went through a few examples in class. So in our notes, we're dealing with the area of a parallelogram. We've got the length. So you could choose either this PQ to be the length, but if that is the length, our perpendicular height is over here. We do not know this value, so PQ is not a good option for the base. Instead, if we choose this portion, QR, 6 cm as the base, you can rotate your paper and you'll see that this dotted distance here will be the corresponding perpendicular height, 9 cm. Therefore, that is the option we're going to use. Base of 6 multiplied by the perpendicular height 9, you get 54 square centimeters. Similarly, for part B, choose our base multiplied by the perpendicular height. There are two options. We do not know this xy distance. We do not know the perpendicular height over here. So this is not useful for us. Instead, the question provided the base to be x, and when you extend it, like the way you extend to find the perpendicular height of a triangle, you've got your perpendicular height over here, 3x plus 4. Therefore, the area is simply 3x plus 4 multiplied by x. You do your expansion, so 3x multiplied by x gives us 3x squared. 4 multiplied by x gives us 4x. So all these in square centimeters. Move on to the next exercise. Oops. So we've got exercise number 2 now. So here we have bx and by, they are the altitude. So it is just another way of saying the perpendicular height of this parallelogram. in further information given is that our AB is 12 cm, AD is 8 cm, DX, this perpendicular distance, is 6 cm. So first, find the area of the parallelogram. You can either memorize the formula, or every time you want to find the area of the parallelogram, imagine cutting out the triangle DAX, you put it on the other side. You form a rectangle. So the area is going to be the length times the breadth, or base times the perpendicular height. Same thing. So our 12 cm here, after you form the rectangle, 12 multiplied by the height of the rectangle, the one we choose will be 6. So that gives us 72 square cm. And then recall that they like to ask you to find the length of BY. So this time BY is our perpendicular distance if our base is 8 cm. The area doesn't change. So use that to our advantage. Our area of the parallelogram, DA multiplied, so 8 multiplied by the distance BY, has to be the same area as the parallelogram. And now we take our pencil, we want to remove that 8. No, all these are not pencils. So we just use red color to represent a pencil. Divided by 8 on both sides. And now I'm left with BY, which is what the question wanted. 72 divided by 8, you get 9 cm. Okay, next one, exercise number 3. We've got another parallelogram, PQRS. So always double check the question, what is listed with the diagram. SR is 12, PS 9, PS is 6, and they tell us N is on the line PS produced. So let's see PS, we produce it, so we extend it. And they tell us further that PN is perpendicular to RN. So in a way, we have our perpendicular height already, if you choose 6 as the base. And they further tell us that SM is 5, find the length of RN. So RN, this is the part that they want. Once you understand the question, we need to form a plan to get our answer. Okay, so we'll observe. Okay, NR is perpendicular to PS, which means that if I have the base PS, I multiply by this unknown, which is what they want us to find, I will get the area of the parallelogram. Okay, so now the problem becomes, can I find the area of the parallelogram without using this information? So turns out they provided the length of PQ, which is the same as 12, and the perpendicular height of 5. So I can find my area of the parallelogram. Let's put that all together. Area of the parallelogram, we've got 12 multiplied by 5. This has to be equal to our other base, which is PS. So that gives us 6 multiplied by the corresponding perpendicular height of NR, or we call it RN, same. You have now formed a formula. Our job is to get rid of that 6. So we divide by 6 on both sides, do a quick switch in the places. So Rn is now equal to 2 times 5, which gives us 10 meters. So what we have just done is something that is a skill that we have used in the previous set of notes for finding perpendicular height of a triangle. Okay, so try this exercise 4 now in class. Do now. So just pause the video here first. Okay, now that you have attempted it, our question tells us that ABCD has an area of 72 square centimeters. They also told us the perimeter is 36 centimeters. So for perimeter, always good to use your finger, trace the outline so that you know what you need to add. They also told us that DE equals to 9 centimeters. So DE, we are talking about this perpendicular distance here, 9 cm. So perpendicular distance will be related to our area. With these two information, we can now find out what is our AB, which is what the question wanted. So let's put that all down in our formula for area of a parallelogram. So our base will be AB, that's what we want to find out. Perpendicular height will be 9 cm. 9 times AB has to give us the area, which is provided to be 72. We now want to remove that 9, so you divide by 9 on both sides, leaving us with AB equals to 8 cm. Okay, so put that down, 8 cm and 8 cm. Opposite sides of a parallelogram are equal. Now they tell us to find BC. We will now use the perimeter information, 36. So 8 plus 8 plus whatever this is, which is the same here, gives us 36. Put that all down. 8 plus 8 plus 2 of the unknown BC has to be 36. So let us get rid of the 2 8s. How do we do that? We simply subtract 16 on the left hand side. You subtract 16 on the right hand side, to be fair. We're left with now 2BC equals to 20. We want to get rid of the 2 in front, so we divide it away by 2. And finally, BC must be 10 cm. Finally, we move on to part B. They tell us that the area, the ratio of area DFC. So let's clear some of these things. Put in the information that we found. This is our 10 cm. Okay, so now the question is saying that ratio of the area DFC, okay, we've got a triangle here. This ratio to our ABCD, oh, that is the entire parallelogram, is 3:10. So 3 units, 3 units over here, 7 units for the rest. So that gives us 3:10. Find the ratio of FC to BC. This is quite a unique question. But if we look at what is the relationship between FC and BC, they are the corresponding bases of a triangle. So FC, this FC here, is the base of this triangle, with this as the perpendicular height. Also, we've got BC over here, which is the base of the parallelogram with the same perpendicular height. Okay. So now we have something to work with. We can write down the ratio of the areas first. Let's start with the triangle. To area ABCD. From the question, they told us that it is 3:10. From our formula, we know that area of DFC will be half times the base is FC, times the height, which is DF. Okay, so let's just use DF since it is provided. Now for our parallelogram, our area will be the base. The base is BC multiplied by the perpendicular height, which is the same, DF. So we see, hey, there are some information that is the same already. Use a pencil. You can cancel both sides. You can divide both sides by df. Okay. Now, we are left with half times FC to BC has the ratio of 3:10. So we can put it down in our fraction. Remember, we talked about ratio. If we convert it to fraction, sometimes it makes it easier. So currently, we have half FC out of BC is the same as 3/10. Okay? Since we want FC to BC, we want to get rid of this half over here. This one. We do so by multiplying by 2 on both sides. So we multiply this by 2. Then to be fair, you also multiply by 2 here. The result will be FC to BC is 3:5. So the ratio that is required, answer 3:5.